Well, we haven't quite finished with this amplifier yet. I turned the amplifier on this morning. This is the classic D Class D amplifier I built. Notice it still does not have a volume knob because it still has not arrived. We'll cover that later. Anyhow, I turned the amplifier on and this light didn't come on. I'm like, did the LED blow? And on closer inspection I could see that it was glowing very dimly, so there wasn't any current flowing properly through the LED there. So that indicated a bad connection at either end of the plug of those sodding connectors that I hate. I have done some investigation and there is a specific engineering crimping tool which does multiple sizes that will work with this. It's about $60 and it's made in Japan. I may order one and I'll see if it makes it any easier. Anyhow, so what I did was off came the top and it turned out to be at the board on this end. And it was the first connection in the socket, so pulled the plug out with the amplifier turned off, pulled the pin out of the socket and re-crimped it harder with a pair of pliers and put it back in, turned it on, the light came on. I verified that it wasn't like anything else by switching the channels, and every other channel including the tape worked and all the relays worked except the video one. So anyway, after I re-crimped it I put it back together, turned it on, and yep, the light came on. So in order to test whether or not I'd crimped it properly this time, I just pushed on the wire at the back of the board there that it's connected to the socket, and I heard this loud popping and banging coming through the speakers on the desk. So there is now another connector in there with a bad connection. And sitting in this state here as it is on the desk, it's not going to cause a problem, but over time, yeah, it could cause an issue. So what I'm going to do is I'm going to take the top off. Okay, so the screws are already removed, off with the top. And now that I have the video camera running, I doubt it's going to do it. There's the wire with the red trace is the one that was the dicky connection. I repaired that, and as soon as I pushed on the wire, which was coming into contact with these audio leads under it, it started making a noise, and of course now it's not going to do it. So good thing that that power switch is insulated. Yep, and of course it's not going to do it. So I'm just going to check every single connection. I believe it's one of the ones on the volume board. I mean, now that the thing's been running for a few hours and it's hot, that connection's probably expanded in the socket, so it's making good contact. So unfortunately, as always, as soon as you turn the video camera on, you cannot duplicate the issue. Isn't that marvelous? Anyhow, I believe it's one of the connections before the power amp, so I reckon it's actually before the volume control, because the volume does actually make a difference. If it's turned right down, it's not as loud through the speakers, so it's not the output to the power amps over here. It'd be more likely probably the connector that's right under this power that you can't get to. Now, there is another possibility. I was thinking that maybe if pushing on this power connector for the tone amp was coming into contact with the ground lead for the, I believe that's the audio output of the volume board underneath, and shorting the power out to ground there, which would cause it to make the noise. But then if that was so, that would mean the whole entire circuitry in here that's powered off the same rail would also be affected, and therefore it wouldn't matter where the volume control was. So I don't think that's the issue. I did pinpoint it to this wire, which is the output to the power amps, but because everything's all tied in, it's pulling on everything else as well, so it could be any of them. But it's not doing it now. So that was totally pointless, and that fart stunk. Now, that just goes to prove that I'm not infallible. I make mistakes. I reckon it's one of the grounding connections on those audio leads is not quite making good contact. So what I should do really is pull them out of the connectors and then just touch them with the soldering iron to solder the connector to the wire so it's making good contact. I don't think it's the contact to the pin that's the problem. I think it's the wire to the contact that is the problem. So I was hoping to do a bunch of tests to pinpoint where it was coming from, but now it's not doing it. I can't. So, well, I think we'll leave it there and move on to something else. I'm going to end this video with the new volume knob when it comes. So this will be uploaded in probably a week or so's time. So what I'll do is when I get the knob and put it on, I'll then go back and try and duplicate the problem when the amplifier's been off and sitting for, you know, 12, 16 hours or whatever cold. So I reckon it's only going to do it when it's cold. So we'll wait until then. I'll go through and do the tests again and try and pinpoint the thing, because if it's intermittent like that, it's going to come back any time it wants to. So, and as I said, large thumps like that going into the power amplifiers, which are quite capable of 160 watts output per channel, into bookshelf speakers like that on the desk here, which are only capable of 25 watt RMS and 55 watt peak, yeah, they won't last very long, put it that way. And those were like $25 drivers, and I don't really want to blow them up because I've only had them for about 4 months. So yeah, I'll move on now to the volume knob when it comes. For now, I'm just going to leave the screws out of the top, which means I have to be careful, because if I put anything on top of it, it can slide the lid sideways off. So what I might do is I might actually just run one of the screws in one corner here just to stop it from sliding off. I have a knob. It's finally came. As wrong as that sounded. Let's get this out the bag so you can have a look. It was wrapped in a piece of paper, but I've obviously got rid of the piece of paper. But that's the knob there. It's yeah, okay. It's a little smaller than I was expecting. The other one must be about 44, 45 millimeter. I can't remember offhand, but this is 38. So it's still going to look pretty small on the front panel, but a little bit better than the one that I was going to put on it. Here's the one from Ultronics as comparison. As we can see, there is a significant size difference there, but 38 millimeters, all right. And of course, it's got a 6 millimeter hole that I need to drill out to 6.5 because it won't fit my shaft. But yeah, it'll look something like that on the front panel. Yeah, we'll get to that later. So this has been sitting for about, I'd say 9 hours or so, not turned on. So what I'm going to do is I'm going to turn it on, wait for the relays to engage, and then dick around with the audio wires back here and see which one is causing the issue, if it's causing an issue anymore. Yeah, and of course, it's not doing it anymore. I'm pulling on every lead and nah, it's not doing it. So that problem has ceased to exist, which is, yeah, okay. However, I do have to make one modification. Just turn that off for now. The headphone amplifier, apart from that LED being a little bit too bright, the headphone amplifier is putting out a lot less into the headphones in perceived level, that is, as the speakers are. So the speakers tend to be louder than what's coming through the headphones. You'd think it's around the other way, but that just means that the amount of gain chosen for that feedback loop there in the op amp stage is not high enough. Now I can't remember what the actual gain was offhand without looking at the schematic. So here's the two resistors in question here that control the gain of the op-amp stage, regardless of the fact that these transistors at the output are part of the feedback loop. We've got the resistive feedback here, and we'll call this R1. So gain is calculated 1 plus RF divided by R1. And what do we get? We get a gain of, well, 2.2 plus 1, which is 3.2. So from what I could tell going into the headphones, the level needs to be closer to probably half itself again louder. So I would go out on a limb here and say a gain of maybe 4.7 instead of 3.2 would be a little bit more appropriate. Now I can modify either the 2K2 or I can modify the 1K. Or I could modify both. So the next question is, what would I need to change those resistors to get a gain of 4.7? Well, I could just change the 2K2 to a 4K7 and that'll give me a gain of 5.7 and be done with it. Or I could put a 3K3 there and make it roughly 4.3. It's really a toss-up between the two. I don't have any 3.3K resistors, so I'm just going to go with 4K7 because, well, that's easy enough to get hold of at the moment. Of course, unfortunately, that means that that front panel and all its knobs have to come back off again. And the tone amp board at the top has to come out of the way, and the headphone amplifier and sub control board has to come out from underneath there so I can get to the underneath of the side of the circuit board. As for that speaker protector board back there, the resistor that's driving the LED or dropping the current through the LED sits at 10K according to the instruction manual I got in my hand here. I could increase that resistor to 22K and that should give me about half the brightness, which should, in theory, be the same brightness as the rest of these LEDs. So that's what I'm going to do, is change that 10K resistor in this speaker protector that goes to the LED, which I believe is that resistor there. I mean, it's just unscrewing the board and propping it up out of the way, to a 22K, just to lower the current going through that LED. And take this all apart and adjust the gain. Now, I can't find or replicate the fault that it was experiencing the other day. It's been cold, off all night, and all the connections are good. So, mustn't have been something seated correctly, and I've just reseated it when I was dicking around with it. But if it happens again, well, yeah, I can fix it later. But it's not doing it now. That's the main thing. So that means all these boards have to come out. And it's quite an involved process, but I want to see how well I made this serviceable. Like, how easy did I make this serviceable? That resistor there where my finger is connects directly to this pin over here on the connector, which is the anode of the LED at the front. So that's the resistor I need to change. And I've got a 22K resistor sitting there ready to go. Now I can just unscrew this. Lucky that was off, and I don't know where that went. Ah dear. Where did you go? That's the one thing I hate doing, is dropping screws into something and then not seeing A, where it dropped, or B, where it landed. So now I can't see where that screw is at all. That's wonderful. I'm going to have to turn the unit upside down or sideways or something and shake it until the screw falls out. I cannot see the screw anywhere. It's probably gone underneath one of the circuit boards. It sounds like it. So let's see if I can just get this to come out. Yeah, well, it rolled. Ah, I see it. Can you see it too? See if I can get this. The camera's in the way, but there we go. Right, so now that problem's sorted out, I'm going to have to figure out how I'm going to hold this upright to get to the resistor. So I might, good question. Alright, well that seems to work. I'm just using that handy dandy tool with the claws on it, sitting at the back of the amplifier, just sort of like one of the alligator clips, just holding the board there. So the resistor I need to take out is across these two pins here. So hopefully I can do this. Don't know how well you're going to see anything, but even if it's that interesting to see. I don't think, it might have done. Well, it did actually suck the solder off. Now if I get a screwdriver behind it and just gently pull one end out at least, I can then grab hold of the other end. A pair of pliers whilst supporting the board. And yeah, I knew that was not going to come out very easily. Okay, so the easiest way to do that is to just heat it with the iron and give it a pull. And there it is there. And I'm going to put this in place at the 10k now, which is now 22k. I'm going to put it round so that the bands are red from left to right. So it's that way. I mean, resistors aren't polarized, and the joke about, you know, you put all the bands around the same way so as the electrons don't fall out, well, it's just a joke. It's more about readability than anything else. Like if you're looking at one resistor one way and you're looking at another resistor that's the same orientation as the first one but the bands are around the other way, you have to constantly turn the board around and read it properly, unless you're good at reading things backwards, that is. So we just solder this one in place. Alrighty, we're ready for a test to see if the brightness is about right. Should be a lot lower than it is, or was, I should say. Now I've got everything all piggly here. So I'm going to plug the mains back in. Alright, contact. Still a bit on the bright side, but it's not as bright. So yeah, it's a toss-up to change it to 33k or 47k, but no, I think I'll leave it at that. 22k should be enough of a significant drop. Just one thing to note about this speaker protector with this protect LED here with the 22k that I changed. In normal operation, this LED will not be lit because ground is being brought up via this MOSFET here, so it's essentially shorting that LED out and allowing the relay to energize up through to the positive rail. Now when the relay drops out, now there's a resistor here of 820 ohm, and effectively now this relay coil is appearing as a resistor because it does have a resistance. I think it's 860 ohm or something. Anyhow, so you got that plus the 820, that's appearing to the LED down here as a resistance of, let's say, 1700 ohm, 1.7k as a rough figure, and allows the, well, positive to flow through this resistor here, through the LED to ground. And that's how it lights up. And also how it turns off when the thing is not in protect. It's quite interesting. Well, at least I thought it was. Now to work on the headphone amplifier. So I need to unplug that. I need to take off all the knobs. Fun. Well, I can find the screwdriver that I need to do that with. So I'll just do all the knobs first, and then I'll worry about taking the bottom off. Okay, so knobs off. Well, you saw the Astro 30 build it, and now you're seeing the Astro 30 take it apart again. I didn't actually plan on having to take it apart, but I was listening through headphones the other night and I thought, yeah, gee, that's a lot less volume than what's coming out of the speakers. I've turned the volume up even further to hear it properly. And I'm like, yeah, there must be a gain issue with the headphone amplifier, so I need to increase one of the resistors, or one of the resistor values. There's two of them. So I've decided on 4K7. That should give me almost double the amount of gain that was there before, which is about right, because what's coming through the headphones sounds about half the volume of what's coming out the speakers. Albeit that, yes, different headphones give different impedances, and therefore there's going to be different voltage outputs. Geez, that's tight. That's the only screw that didn't line up, because the panel seems to be, I don't know, seems to be warped at the bottom here. And I couldn't see any physical reason as to why. So, anyway, pull the bottom cover off now. Now, I'm not sure, but it looks like that is warped. So I'll take the screws out of the bottom side here. I'll pull the panel off and I'll have a look. I might have to put it across my knee and just give it a slight pull. There's no reason why anything behind the front panel should be pushing it out like it is. So I'll bring that forward a bit. Right, so the front panel will hang down out the way just like that to make it easy for servicing, I guess, but I want to find out what's wrong with the panel itself and why is it warped. I think I may have just straightened it slightly. I really don't like the idea of having it hanging down by the power switch like that, but yeah, it is what it is. Okay, that was a considerable effort to get out, but it's out, and I want to get this right the first time. One resistor is here that I need to change, and the other one is next to this transistor over here. So, and I can probably tell that that'd be the one I reworked anyway. One of them is. So I need to get this resistor out and change it. So I will. Sorry about the angle, guys. I know you're not going to be able to see much, but trust me, it's not all that exciting anyway. I just want to carefully remove these resistors. I'm going to do one at a time so I don't accidentally mess it up or anything. That's one end out. And one end's going to stay connected as I expected. There we go. That one's out, so that's one. So I need to find a couple of 4K7s, pop them in, and Bob's your auntie. Okay, so both resistors have been changed now. I need to reassemble it all back in the case. I need to then turn the case upside down and tip out the solder dags that went everywhere. Came out the end of the solder sucker. And then I can test to make sure that that works. This board was fun to take out with all the wiring in the way. It's going to be even more fun to put it back in. And of course, wouldn't you know it, it's a lot easier to assemble than it was to take apart. Funny that. Now, I did look online at some different types of switches and stuff at one point the other week, and I know there is actually a connector that suits this type of power switch that I used, which means it can just simply unplug. Well, I know that for future reference now. I didn't know that at the time when I ordered the switch. If I'd known that, I would have actually ordered one. So it might help if I plug all the audio connectors in first before putting the second board in, and then I'll tighten everything up and re-ground the pots. So that needs to go there, that goes there. See, I don't understand how This was so awkward to take apart, yet it's relatively easy to put back together. You forgot to remind me to tip it upside down and get all the solder dags out, but I remembered. Anyhow, nothing unusual, so I really need an audio source, don't I, first? That might help. Okay, I've got an audio track ready to go. I've also got the headphones ready too. Turn the amplifier on. I'll just start playing this track. Now if it's not going to come blasting out, we'll soon find out. Might help if it was on the right input. It helps to connect the other speaker. It's better. Oh, why there was no left channel. Alright. Oh yes, that's a definite improvement. That sounds a lot better now, so I'm happy with that. Right, the issue I've got is the top lines up fine, but the bottom does not. So there is a slight bend. So let's take this off carefully. Let's see if I can just give it a little bit of a helping hand there. It just happens to be right in the middle too. Let's see if that made a bit of a difference. Might take a little bit of effort to do this, but that's what I should have done in the first place, but I didn't. That has not made any difference. I mean, have a look at the gap here. See, this is the gap I'm dealing with. The screw's almost there, but there's about 3mm gap here, no gap at that edge, and no gap at that edge. So it's bent in the middle, and there is nothing in the middle here behind it that's interfering, or should be. I'm not really sure what's going on here, because I am trying to overcome this straight bit, which is going to be awfully next to impossible to bend. Oh, that's much better. Yeah, I've taken off about 2mm of that now, so I can safely say that's going to be straight enough to not be stressing the screw to pull it straight. So a little bit of a gap's fine. You know, it's not that much of a bigger deal. But I wanted to get as much of the bow bend out of it as possible so the screws don't snag when you're trying to do the thing up. Now I shouldn't have to put the top screws in just yet. I can put the bottom panel on without having to do that, because the thing is straight anyway. So this hopefully is the last time this cover needs to come off. Okay, I believe the top does not need to come off, so that can be screwed back on now. Start with the middle screw. Okay, turn that to where it needs to be. Okay, so that's the knobs on. Now speaking of knobs, I've got to turn my attention to this one. So I need to work out how deep this hole is and how much deepness it's going to be on the shaft, if that made any sense. So I'm going to take a 6mm drill bit. Maybe should remove the grub screw out of that first. It's like giving birth. Here we go. There we go. There's the grub screw out the way. Put that somewhere safe. Now I'm going to take my drill bit, which is 6mm, and that barely fits down the hole, but put it down the hole, and then I'm going to take a bit of marking tape, masking tape, put that around the drill bit, roughly where it comes into contact with the edge, just so I can see how deep it is. That's probably about close enough, and then I can take the drill bit out. That gives me some form of viable measurement. So if we look at the shaft of the potentiometer, yeah, that means it's going to bottom out probably about 4 mil before the bottom of the shank. But don't forget, you've also got to take into account this lip, this recess. So that's going to add an extra probably 4 mil to it. I can't really see because it's black. So if that's where that bottoms out, you've got to add an extra 4 mil. So I could probably bullshit that a bit by just adding a texture mark or something to where the edge of the knob is, which is going to be about there. If I can get it back out. Yeah, that goes almost all the way down to the front panel. So that means I don't need to drill that deep. I could come back up a couple of mil. So I'm going to measure what that is. We are looking at good 15 mil. So if I bring that back to say 12 on my 6.5 drill bit and actually wrap the tape around at 12 millimeter instead of 15, that should give me just enough depth. Okay, I've got the drill bit marked. I've also got the knob clamped into the drill press clamp. So now all I need to do is just drill it out until I reach the line of this tape. It's all very technical, but it works. There. How easy was that? Now I don't think I went all the way down. It doesn't look like it. Oh yes, that's perfect. Probably could use a little bit more. Not much, but I'm going to pretty much safely say I'm going to leave it there. I think that's on there properly. Yeah, it's not getting any tighter than that. Check it out. We have a volume knob. Woohoo! Now that I've got my knob, I'm going to sit there and play with it all day. No. Well, that pretty much be it. The amplifier is now complete. And I've done a couple of modifications that I needed to do, which was increase the gain on the headphone amp, which I've done, decrease the value of the resistor, increase the value of the resistor for the protect LED so it's not as bright. Done that. So, and I've fitted my knob. I couldn't chase down the original fault that it had with the connection issue. It seems to have gone away. So I'm going to leave it alone whilst it's working. Anyway, I'm going to leave this video here, and if you enjoyed it, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyways, this is the Astro 30 saying, see ya, have fun playing with your knobs.